All right, we're going to look at what's called arc length. Okay, so it's just like it sounds. We're going to take, like, we know what an arc is, right? Like a curve. All right, we're going to take the curve off a piece of a circle and figure out how long would it be. Now, I'm going to look at this from a unit circle approach first to show you, you know, why in some senses that radians is better than degrees, and it certainly is when we're talking about lengths. So let's look at like pi over 3 at my unit circle, which is 60 degrees. Okay, now pi over 3 tells me that location there too. But if I wanted the length of how long is this arc from 0 to pi over 3, like if I take it off the circle and stretch it straight and I measured it with a ruler, how long would it be? Okay, now the thing about in radians here is that would tell me that the length would be pi over 3. And see, 60 degrees couldn't tell you that. 60 degrees is not a length, it's just an angle measurement. So a radian is an angle measurement and a length at the same time. Now, that only works because the radius of the unit circle is just 1. Okay, you change the radius and that kind of messes it up. So let me show you what we're really finding here with arc length with an example here. Let me draw a circle and we'll throw a old geometry term at you. All right, this is when you have an angle and the vertex is at the center of the angle, or center of the circle. That's called a central angle. Okay, so we're going to say this central angle is pi over 4. I know it's kind of hard to read. It's kind of small there. This will look better, I guess. Now, the arc length would be like if we took this little piece off that circle, snapped it out, and stretched it straight and measured it. Okay? Because, well, we usually can't measure things in a curve, can we? We kind of have to straighten them out. I guess you could with a really good tape measure. But really what we're looking for is this distance right here when we say arc length. Okay? Now, you have to have a radius to go by. So let's say that the radius is like 4 centimeters. Okay? Now, what you have for arc length here is you have a formula. And it's real simple. It's over there on the left. It'll be up there for you test too, so you don't have to memorize it. Okay? Arc length S is equal to R times theta. So it's pretty simple formula. All you got to do is say the radius times theta represents the central angle, theta. Okay? Now, the only catch, though, there's one catch that makes this remotely difficult. What do you think this has to be about theta, though? Right? What did I tell you about lengths here? When I told you about pi over 3, that would measure the length, but 60 degrees would not. All right, somebody said it. It has to be in radians, because radians can measure length. Degrees cannot. Okay, so the angle has to be in radians. So what if it's not in radians? I know this one is. You got to change it. Okay, that's the biggest deal with arc length. Okay, now all we're gonna have to do is just throw it in our formula right here. So we just say the radius is 4 times pi over 4. Okay, now that would be pi. Now most of the time what we do is we put it in the calculator and round it to like the 10th place or something. So that would be pi because the 4s would cancel out. So to like 1 decimal place, we just say about 3.1. Now what's going to be the units on that? Centimeters. Okay. Now somebody said radians, but remember radians is the only unit that you don't have to write. So really it's radian centimeters, but we don't have to write radians. Now, so y'all understand like the concept of what you're finding right there? Okay. Right. And really what you're going to end up doing is just punching everything in on the calculator anyway. Okay. No. Okay. You don't have to change it to radians. The only time you have to change your calculator radians if you're finding the sine, the cosine, or the tangent of the angle. Okay. So if you're hitting your sine, cosine, and tangent button, that's when you might have to change to radians. Okay. Now, And so you're not doing that. You're just hitting these two in. Now, let's look at one. Let's do this one. All right, let's say, oh, and by the way, let's look back at this. Now, do you see how that the length here from 0 to pi over 3, it's actually a length too? Because again, what's the radius? What's the radius on the unit circle? 1. And so 1 times whatever the angle is just going to be the angle. So if it's in radians, see all of these marks, they not only represent the angle measure, but they represent the lengths. Okay, so that's why radians work a little bit better than degree measures. All right, let's try this one. Let's put in this angle. All right, let's say our angle is 80 degrees. And let's say our radius is like, I'm going to use something different. Let's say 14 centimeters. All right, so let's see what gives. Can we just throw it in the formula here and say, all right, S equals R times theta. So what? 14 times 80 then, right? No. All right, theta has to be in radians. So let's switch it over. Okay, so we know how to do this, right? We know how to switch degrees to radians. All right, what's our conversion factor? All right, other way around then. The pi goes on top. Okay, so the degrees cancel. Okay, now this would give me 80 pi over 180. Okay, so now we could reduce it here. So that would be what? 4/9, so 4 pi over 9. Now realistically here, because the directions are going to ask you to like round to the 10th place, you don't have to put it in terms of pi. Okay, so you don't really have to go through all this. So all you'd have to really punch it in your calculator would just, y'all punch it in for me because I don't have mine up. Oh, there's one. I was looking for that. All right, so really I just punch in there 80 pi over 180. Okay, so that's about 1.3, well, 1.40. Okay, so now that's that angle in radians. Now we can find it. Okay, so what are we going to do for our arc length now? All right, yeah, 14 times 1.40. Now, when I punch this in my calculator, right, we're going to use answer, right? So it's accurate. All right, so that's why we don't have to put it in terms of pi, is because we're using all the decimal places. All right, now if they ask it in the form of pi here, we would have to say 4 pi over 9 right there. All right, so let's see, we got 14 now times that, so we'll use answer there. All right, so our length is about, let's just go to one decimal place, about 19.5. All right, what would my units be in there? Centimeters. Okay, so y'all see, like, the only thing remotely difficult about it is that the angle has to be in radians. Okay, so you might have to change your angle to radians if it's not given in radians. All right, do we need to see another example? No? Okay, good. All right, let's do what's called the area of a sector, because it's very, very similar. All right, now this is actually on the next page. I think it's on page 346, or I'm sorry, 347. Yeah, 347. Yeah. Okay, let's find what we call the area of a sector. Okay, now the best way to think about, well, what's a sector? Best way to think about that is it's like a piece of pie. Okay, so you know when you get like a pie, I like apple pie with like the little crumble cinnamon stuff on top. I'm like starving now. All right, so think about like a piece of pie. Okay, like that. So that would be a piece of pie, right? So that represents a sector. And so if we cut a pie evenly here, the angles should be formed with the center, shouldn't they? So they come from central angles. All right. So the formula for the area of a sector, all right, it's over there to your left. All right, it's just 1/2 times the radius squared times theta. All right, but guess what the catch is? Got to be in radians. Okay. Now, all right, let's do an example. And let's do an example where the angle's not in radians. So if it's in radians, I mean, you just throw it in the calculator and that's it. Okay. So let's do the area of a sector here. And they don't draw pictures for you. They just give you the information usually in the problems. I like to draw the pictures so I like know what I'm finding here. So let's do this. I'm gonna do like more of a me-sized slice of pie. Okay. Yeah. So yeah, I'm not. That's not enough. I want this, and I want ice cream on it too. All right. So let's find the area of this sector. All right. So the things that we got to know to find the area is going to be the radius and the angle. Okay. Let's say that the angle is a nice 120 degrees. So I'm eating like a third of the pie. Okay. Let's say good radius here would be about 5 inches. And that way it would be a 10-inch pie. Okay. All right. Now, let's see if we can find the area. Now, so we got to change that to radians. Now, let's be smart. Don't work it out. Figure it out. R, A equals 1/2 r squared theta. Oh, that's 5 inches. How much? All right. How'd you get that fast? Thank you. Unit circle, right? 120 degrees is an angle that is on the unit circle. So I can just like peek at my unit circle and see 120 degrees is 2 pi over 3. Okay. So now, could we have done that if it was 130 degrees? No, you'd have to convert it to radians. Okay. But we're still converting it to radians. We just don't have to do all the work, do we? Okay. What was it? 2 pi over 3? Okay. 5 inches. Okay. Now, let's put in our formula here. All right, 1/2 times, all right, what would my radius squared there be? 25. Okay. Now, we're not going to say, what, 120. We're going to say 2 pi over 3. Okay. And that doesn't even have to be in terms of pi there. All right. So, probably if you were converting 130, you could give it in the form of a decimal. You just have to be sure to use all the decimal places like we always do with the answer function. Okay. Now let's punch all this in. All right. So 1/2 we can just do 0.5. All right. Times 25 times 2 pi over 3. All right. Just use a division symbol for 2 pi over 3. All right. So this is going to give me, let's just go to one decimal place, 26.2 inches squared. Okay, why squared? Because it's area. Okay. The radius squared. Okay. And so really, I mean, you didn't even have to do that, could you? You could have just hit 5 squared on your calculator and not even worry about that. All right. You want to do another one real quick? Let's do one more, and then I'm going to let y'all do some from the textbook, okay? All right. So, I mean, they're just simple formulas. You got to throw them in there, but they got to be in radians. All right. So now let's find Autumn a piece of pie. Here we go. So I'm pretty stingy. I'm going to give her a piece about that big. Okay. And it's only going to be 10 degrees there. She's pretty hungry. I mean, she's not very hungry. I know. All right. And let's say that this is, y'all make up a number. All right, 3 feet, and that'd be a big pie. Okay. So now that really would be a big piece. All right. Because there's a 6-foot pie. All right. So that's a pie about the size of a grown man. That's how wide it would be. All right. Now, All right, so let's see. Let's find the area of that little piece of pie there. All right, so area is equal to 1/2 r squared theta. Okay, so we do what? 1/2 0.5 times 3 squared, which if we wanted to, we could just write 9, okay, times 10 degrees, right? No, that's got to be in radians, okay? So let's swap it to radians, and that's not on my unit circle, so I got to do it out. So 10 degrees, all right, let's switch it to radians here. Degrees cancel, so it's going to be 10 pi over 180. Now, what we're going to do here is you don't have to give it in terms of pi. Let's just calculate it on the calculator. Okay, what is 10 pi divided by 180? All right, so about 0.17. All right. Now, the only thing is when I push this in on my calculator, we're going to bring up all the decimal places. Right, we're going to use the answer function. So 0.5 times 3 squared times now answer. Okay, now there's going to be my area. So about 0.8 if we go to 1 decimal. All right, so about 0.8. Now what would this be in? Feet squared, okay, or square feet. Okay. All right. Now, does that make sense to us? This is really usually an easy lesson. Okay, so I just throw it in the beginning or the end of the 6 weeks. Just throw a couple of questions on the 6 weeks test. Now, y'all, hang on, I forgot which ones I assigned. All right, y'all look in your book, page 349. And let's just do some quick practice with this. All right, y'all look here, 36 through 39. And then 46 through 48. Let's get it done in class because you can finish it. Yeah, almost 15 minutes. You'll finish it before then. All right, y'all got this written down. Just to put the answers up for you. All right. Tuesday and Wednesday. Okay. And on that test, along with all this other stuff, is I'm gonna give you 2 questions. One with area of a sector, one with arc length. Okay. So, and you can bet, your angles are probably not going to be in radians for you. So you're gonna have to switch them to radians.